This is a 5 marks question. Question says sketch the waveform for the bit stream, this in the differential Manchester encoding format. For this, we have to know these four transitions. For this zero, whenever bits value is zero and we are at a lower voltage, we will take this transition. When we are at a higher voltage, will take this transition. And for a bit value 1, when we are at a higher voltage, we will take this transition. And when we are at a lower voltage, we will take this transition. So this indicates higher voltage and this indicates lower voltage. Now we will draw the sketch form of this waveform. 100 1011 First bit is 1. That means initially we start from a higher voltage always. That means we are here and we come across 1. That means we have to take this transition. Now next take 0. Where we are at a lower voltage and we come across 0. So at lower voltage, we will take a transition of this one. Now we are at a again lower voltage and the bit value is 1. That means we will take a transition of this one. Again it is 1. We will take a transition of this. Then next is 0. We will take a transition like this. Again it's 0. Now next is this is 1. This is 0. 1 1 0 0. Now next is 1 again 0. Now for 1 we are at a lower voltage. For 1 it will be like this. Now we are at a higher voltage and the value is 0. So we will take a transition like this. Basically, if we look at this transition, what is happening? Whenever we come across a value 1 and we are at a higher voltage, then we make a transition and come down to a lower voltage. And if the bit value is 1 and we are at a lower voltage, then we are making a transition and we are going up to a higher voltage. If you see, and when the value is 0 and we are making a transition, then in that case we are coming back to, if we are at a lower voltage, then we are coming back to a lower voltage again, and we are at a higher voltage, then we are coming at a higher voltage again. That means in case of 1, our voltage line is changing, and in case of 0, it is constant. We are starting from lower, coming back to lower, starting from higher, coming back to higher. But in case of 1, starting from higher, coming back to lower, starting from lower, going back to higher. So we can remember like this. Now question 2. A binary signal is sent over a 8 kilohertz channel whose signal to noise ratio is 20 decibel. What is the maximum achievable rate? Maximum achievable rate is nothing but the channel capacity. It's nothing but a channel capacity. Solve this question, we need to know this formula, Shannon-Hartley theorem. So we have a formula like C channel capacity is equal to B, that is bandwidth, into log base 2 of 1 plus signal to noise ratio. But signal to noise ratio is not in decibel, rather it's in a linear scale value. And to come linear scale value. And to convert from decibel to linear scale, we have another formula which converts from decibel to linear scale. But let's put the value one by one. So SNR in linear scale will be 10. SNR in decibel is 20. That is 20 decibel divided by 10, which is 2, which gives us 100. Now we will Find the channel capacity, which is B into, so B into log base 2 of 1 plus SNR, which is equal to what? B is base 8 kilohertz, 8 kilohertz into log base 2 of 1 plus SNR is 100. So this value is nearly around 6.658, and this is 8000 hertz, which is equal to 53264 bits per second. Now, they've also asked what is signaling rate. Signaling rate is nothing but the baud rate. So it is same. And it refers to the total number of signal units transmitted in 1 second.